Okay, Jai Hind all. Myself, Dr. Sachin Kumar, working as a professor at Ajay Kumar Gar Engineering College, Ghaziabad. So, in the series of the operating system video, I am going to present CPU seedling algorithm, and in this video, I am going to highlight mainly two algorithms which are considered as the very important algorithms, and these algorithms are round robin and shortest job first. So when we talk about the CPU seedling, first of all, we have to know this concept. Only after we can apply the algorithm. So when we talk about the CPU seedling, initially we have the multiple programs in the hard disk. There are several programs in the hard disk in form of the file, and when this program wants to execute, then program comes from hard disk to RAM and it becomes process. Any entity in the hard disk that is executable is called the program, and when this entity comes into RAM, it is called the process. Since we people are living in advanced computing era, so multiple programs can run at the same time. So multiple programs need to come from hard disk to RAM for the execution purpose. So we have the multiple processes in the RAM, and the responsibility of the CPU seedling is to decide which one should execute. You have here n number of processes and CPU decides which process should execute. This is all about the CPU seedling algorithm. And we have several, CPU seedling algorithms in the literature, just like first come first serve, shortest job first, round robin, priority, multiple queue, multi-level queue, algorithms for the multi-core systems, algorithm for the multiprocessor systems. So we have so many algorithms available in the literature, but here I am going to discuss the mainly two algorithms, in fact exact two algorithms. These are the round robin and shortest job first. So when we talk about the round robin, you have here multiple processes in the RAM, and in the round robin CPU seedling algorithm, process executes in form of the particular slice or particular time slot or quantum. Process is not executed completely. It is executed in form of the parts, and this part is called the time quantum, time slice or time slot. Say for example, for the round robin algorithm, time slice is the 2 millisecond. Then initially all the processes should execute for the 2 millisecond one by one. Then next round will start for 2 milliseconds. One more round will start for the 2 milliseconds and go on and so on until all the processes are executed. This concept is called the round robin. Round robin is very important when you are dealing with the interactive system, because we cannot execute one program in one go. We need multiple slots to execute that process. In interactive system, lot of interaction is made between user and process. Therefore, for the interaction, for the smooth execution, for the better performance criteria, we need the round robin CPU scheduling algorithm. So I am mentioning here example for better understanding of the round robin CPU scheduling algorithm. So I am mentioning here, say, process P1, process P2 and process P3. We have here total 3 processes, P1, P2 and P3. Their execution time or burst times are given, say, 5, 6, 8. This is the burst time or execution time. And time quantum is given, say, 2 millisecond. 2 millisecond is the time quantum or slot. I mean, for the initially P1 executes for 2 millisecond, then P2 executes for 2 millisecond, then P3 executes for 2 millisecond. One cycle is completed. Now second cycle starts, further P1 for 2 millisecond, like this. So ultimately all the processes will be executed. To see here how these processes are executed, I am mentioning here a diagram for better understanding how all the processes are executing. So initially, say I am making here this diagram, and P1 executes for 2 millisecond. Now P2 for 2 millisecond. Now P3 for 2 millisecond. Now one cycle has been completed. P1 once again start for the 2 millisecond. P2 starts for 2 millisecond. P3 starts for 2 millisecond. So 2 cycles have been completed. Now, if we talk about the P1, the total execution of P1 has been done for the 4 milliseconds so far. The remaining time for the process P1 is 1 millisecond. So therefore, P1 will execute for 1 millisecond, not for the 2 millisecond. Still, time slot is the 2 millisecond, but process remaining time is the 1 millisecond. So therefore, process P1 will execute for the 1 millisecond. So P1 is here for 1 millisecond. Now P2 now P3 now P1 has been completely executed, P2 has been completely executed. Now rest of the time of P3 is 2 millisecond. So once again P3 will execute for the 2 millisecond. So if we add these values, then sum is 19 and total summation is 8 plus 6 plus 5 is also 19. So it means all the processes have been executed. So this is a scenario to execute, all the processes in the round robin manner. So here when we compute the performance of any algorithm, then we need to compute various parameters, particularly 2 parameters like average waiting time and average turnaround time. So when we talk about the waiting time for the P1, here P1 processor is immediately assigned to P1. Therefore, initially P1 is not waiting for any time. So here waiting time for the P1 is initially 0, and for this particular P1 waiting time is this. I mean P1 is executing up to 2 millisecond, and now further processor to P1 is assigned at 6. So further waiting time for this particular segment for P1 is 6 minus 2, that is 4. Now waiting time for next segment of the P1 is 4. And now further we compute the waiting time for this particular P1. Then here we need to compute this particular time. So here up to 8 P1 is executed, and now further at 2 millisecond processor is assigned to P1. Now waiting time for the this particular P1 is further 4. So total waiting time for P1 is 8. So in this way we can compute the waiting time for P1. Now similarly we can compute the waiting time for P2. P2 is waiting for the 2 millisecond. So initially 2. Now P2 is here up to 4. P2 is working. Now processor to P2 is allocated 8. 8 minus 4 is 4. So waiting time for next segment of P2 is 4. And similarly up to 10 P2 is there, and now processor to P2 is assigned at 13. So therefore 13 minus 10 is 3. Now in this way you can compute the waiting time for the P2. Similarly for the P3 you can compute the waiting time. Now waiting time for the P3 is here. For the first segment for the P3 is 4. Processor is assigned at the 4 millisecond. So initial value is 4. Now processor is assigned to P3 is 10. So 10 minus 6 is 4. After that processor is assigned at 15, and up to 12 P3 is working. 15 minus 12, 3. So P3 is continuous. So P3 is last segment of P3 is not waiting for any time, because up to 17 processor has been assigned to P3 and immediately next segment of P3 is running. So for the last segment of the P3 there is no waiting time. So we can compute the waiting time for P3 is 11. Now we may compute the average waiting time. This is 8 plus 9 plus 11 divided by 3. This is 28 by 3. 28 by 3 is the average waiting time for the this particular all the processes P1, P2 and P3. So in this way we can compute the average waiting time for all three processes for round robin algorithm. Now we are talking about the next algorithm. This is called the shortest-job first, and shortest-job first is further very important algorithm, and this algorithm is considered as the optimal algorithm, because in the shortest-job first you will have shortest, or you will have minimum average waiting time and minimum average turnaround time. So shortest-job first simple means that any process that has the shortest burst time or shortest execution time, it will execute first. So in this way all the processes should run in the shortest-job first manner. But major challenges here, this is quite impossible to find out the execution time of all the processes in advance. Without executing the process, we cannot compute the exact execution time in advance. We have a lot of challenges are here, but ultimately based on the concept of the approximation, we have certain algorithms. These finds approximate time, and based on the approximation we can run all the processes in shortest-of-first manner. This is the way to execute all the processes in the shortest-of-first manner. For better understanding or better clarity, I am mentioning the example how shortest-of-first works. So, for example, further here we have the processes like say P1, P2 and P3, and here burst time is given or execution time is given say 5, 3 and 8. So, here execution times are given. So, we need to decide the process which execute first. So, as per the burst time, P3 has the least time and P3 has only 3 millisecond. So, therefore, P3 will execute first, and after P3, P1 will execute because P1 has the 5 millisecond burst time, and finally P3 has the least burst time, therefore P3 will execute. So, in this way all three processes will execute. For better understanding, I am mentioning here diagram how these processes are executing. So, first of all, P3 executes, this is P2, this is P3. So, first of all P2 executes, and P2 has the 3 millisecond time. So, therefore, P2 executes for the 3 millisecond time. After P2, P1 executes for the 5 millisecond, and after P1, since P1 has the highest burst time, therefore P3 will execute. Now, time will be 16. So, in this way all these three processes are running in shortest-of-first manner. When we talk about the average waiting time, so initially P2, or we can say initially say for the P1 I am writing in sequence. So, P1 is waiting for the 3 millisecond, waiting time for the P1 is 3. For P2, immediately processor is assigned, waiting time for the P2 is 0 millisecond, while waiting time for the P3 is 8. And if we talk about the average waiting time, then you can compute 3 plus 0 plus 8 divided by 3, and this value is 11 by 3. So, in this way we can compute the average waiting time. At the same time we can also compute the average turnaround time. The average turnaround time is the time between submit the job and getting the result. You people also can compute the average waiting time. For example, when we talk about the average waiting time, so you can simply compute the bit. If you talk about the average turnaround time, then you can simply compute the turnaround time by adding two factors. First one is the waiting time and second one is the first time or execution time. So for the P1, since waiting time is here 3 and burst time is 8. So for the P1, you can say waiting time is here, for the P1, waiting time is here 3 and burst time is 8. So 3 plus 5, that is 8. For the P2, waiting time is 0 and burst time is 3. So 0 plus 3 is 3. And for the P3, waiting time is 8 and burst time is 8. So 8 plus 8 equals to 16. Or from the graph itself, you can compute the turnaround time. For example, P1 is executed. P1 is executed. You are getting the result for the P1 is at 8. 8 you are mentioning here. For the P2, results are coming at 3. For the P3, result is coming at 16. So you may also mention turnaround time like this. So for this process, you can compute the turnaround time, average turnaround time. This is summation 8 plus 3 plus 16 divided by 3. 16 plus 3, 19. 19 plus 8, 27. 27 by 3, 9. So 9 millisecond is the average turnaround time for these three processes, while average waiting time is 11 divided by 3. So these two are the important CPU scheduling algorithm. So I have explained how you may compute the average turnaround time and average waiting time. Thanking you very much.